how do we do the monitoring and the mitigation of volcanic hazard. Volcanic hazards pose a serious threat to human life and property. Therefore, it is essential to monitor volcanic activity and take steps to reduce its impacts. Today, several techniques are used worldwide to monitor volcanoes and mitigate their risks. Some widely adopted methods are explained below. Let us see how the hazard monitoring can be done. The primary goal of volcanic hazard monitoring is to understand volcanic behavior well enough to predict eruptions in advance, and to achieve this, monitoring is done through physical and the chemical sensors which are installed on volcanoes, which are connected to a central monitoring station via telecommunications. The next one is on-site monitoring and the data collection during the eruption. The third one is laboratory examination of recently erupted volcanic substances. Monitoring tools and the indicators. Several tools and the signs help in tracking volcanic activity. Next is seismic activity, which an increase in local earthquakes and audible ground signals may indicate that a volcano is becoming active. And the next is ground deformation. Signs such as swelling or uplift of the volcanic structure and changes in ground slope near the volcano suggest potential eruption. Next is gas emissions. A change in the quantity or type of gases coming from the volcano can be a sign that it is becoming more active. Next one is electromagnetic changes. Alterations in the local electromagnetic field are also used to monitor volcanic changes. Obviously, the remote sensing and the satellite and aerial imaging help detect the changes in the area surrounding the volcano. The next is hydrothermal activity. Increased steam emissions, higher temperatures in hot springs or crater lakes, melting of snow and ice, and dying vegetation on the slopes all indicate rising volcanic activity. Next, warning systems. When unusual volcanic activity is detected, it is crucial to issue timely, accurate and clear warnings to disaster management authorities and the public. However, warnings must be carefully handled. False or exaggerated warnings can create unnecessary panic and reduce the public trust, potentially leading to poor responses in real emergencies. So, volcanic emergencies can vary in form and severity. Therefore, warning systems should be designed to each volcano based on local conditions as well as historical behavior. There are two main types of volcano warning system. Let us see. First one is color codes, that is indicating different levels of threat visually. The second one is alert levels, which is describe the seriousness of volcanic activity using descriptive categories. Each volcano may require a unique warning system, and the same warning scale may not be suitable for all the volcanoes. The Alaska Volcano Observatory uses the following color codes. Let us see those colors. Green alert. This level indicates that no volcanic eruption is expected. The volcano is in a calm or dormant state, showing no signs of abnormal activity. It is considered stable and not posing any immediate risk. Next alert is yellow alert. Yellow code means that an eruption might occur in the next few weeks. However, this may happen with little or no further warning. At this stage, there may be small local earthquakes and or a noticeable increase in volcanic gas emissions. These signs suggest the volcano is becoming active but not yet dangerous. Next alert is orange alert. At the orange level, an explosive eruption is possible within a few days and could happen with minimal or no warning. During this phase, volcanic ash plumes may be released, but they are not expected to rise above 25,000 feet above sea level. So, this alert reflects a significant escalation in volcanic activity. Next alert is red alert. A red alert means a major explosive eruption is expected within 24 hours or is already happening. Ash plumes are likely to rise at least 25,000 feet above sea level, which can seriously affect air travel and nearby regions. Strong earthquakes may also be recorded even at distance monitoring stations. This level represents a high risk situation with explosive volcanic activity potentially in progress. Similarly, volcano alert levels used for Pinatubo, that is Indonesia volcano, are as follows, which indicates the alert levels: 0 or no alert. This level represents a quiet state of volcano. There are no signs of volcanic activity and background seismicity and surface conditions are normal. It indicates that no eruption is expected in the foreseeable future. Alert level 1. At this stage, there is low level seismic activity, minor fumaroles activity and other small signs of unrest. This marks the initial signs of volcanic activity, but there is no immediate threat of eruption. Monitoring is increased, but risk to the public remains is low. Next level is alert level 2. A moderate increase in seismic activity and other signs of unrest are observed. Importantly, there is positive evidence of magma involvement. This level suggests probable magmatic intrusion, meaning magma may be moving upward, which could lead to an eruption if the trend continues. The next level is alert level 3. This volcano shows relatively high and increasing unrest such as frequent earthquakes, rapid ground deformation, stronger gas emissions and more vigorous fumarole activity. This stage indicates an increased likelihood of an eruption, potentially within days to a week. Preparations for emergency response may be initiated at this point. The next level is alert level 4. At this level, there is intense unrest including continuous earthquakes, harmonic tremors and visible signs of dome growth or small explosions. Magma is believed to be very close to or at the earth's surface. A hazardous explosive eruption is likely within hours to days, requiring high alert and readiness for the evacuation. Alert level 5. This is the highest alert level. A hazardous explosive eruption is already in progress, often accompanied by pyroclastic flows and an eruption column rising at least 6 kilometers above sea level. This situation is extremely dangerous, especially in valleys and downwind areas where ash and lava flows can cause widespread damage and loss of life. Next, hazard mitigation, that is mitigation of volcanic hazards. Volcanic hazards can be effectively managed through a series of well-planned actions. As discussed earlier, continuous monitoring of volcanic activity, forms a strong foundation for forecasting eruptions and issuing timely warnings. This enables evacuation of people from high risk zones and helps minimize casualties. In addition to monitoring, several other strategies can reduce the impact of volcanic eruptions. Some of them include like this: long-term settlement planning in areas prone to volcanic activity to avoid high-risk zones. Next one is implementation of strict building codes to ensure structures can withstand volcanic hazards. And the third is dissemination of preventive information to people living near volcanoes and helping them stay informed and prepared. And the next is development of emergency management and evacuation plans to ensure quick and efficient response during an eruption. The public awareness and education programs aimed at teaching local communities about volcanic risks and safety measures. Next is loss sharing mechanisms such as insurance schemes and disaster relief programs to reduce the economic burden caused by volcanic damage. A truly effective volcanic hazard mitigation program requires a multi and transdisciplinary approach involving experts from various fields. So, most importantly, active participation of the local community is very essential, and the public acceptance and the cooperation are crucial for the success of any mitigation strategy.